Hello, thank you, and welcome to the booth of blueSPACE and 5G-PHOS, where we demonstrate the current status and the outcomes and goals of blueSPACE and 5G-PHOS. I'll be talking about the goals of blueSPACE, where we use analog radio fiber to vastly improve upon the front haul for 5G. So we want to do away with the current front haul technologies, and we want to use analog front haul for very high bandwidth signals for millimeter wave 5G new radio. So what we have here in the booth is a baseband unit that we have developed within blueSPACE that actually produces high bandwidth 5G new radio signals that we then transmit through an analog optical fiber link towards our remote transmitting antenna. Now in the optical side, the novelty in blueSPACE is that we want to introduce space division multiplexing in the optical domain, meaning in our demonstration here we have a 10-kilometer piece of 7-core fiber. In 7-core fiber we have 7 independent cores within a single fiber cladding, giving us 7 channels that we can use for transmitting independent signals that stay more well synchronized in a 7-core fiber than they would in 7 independent fibers. So this is one of the novelties that we have within blueSPACE. Now in the further part of the demo, we actually transmit the signal towards our remote receivers that convert from the optical signal to an electrical signal. This electrical signal is up-converted by an antenna that was given to us by 5G-PHOS, is transmitted through a 60 GHz wireless link and received by another receiving antenna, where it's down-converted back to baseband and actually fed back to our baseband unit, where we do analysis of the signal quality, and we can show that this link is very, very good and functional here in our demo at the booth. Now, as an additional innovation that we have within blueSPACE, we have optical beamforming, and we actually show an optical beamformer that is developed by our partner Lyonics as an optical beamformer as an integrated module, where we have lasers and the optical beamformer in one package, and we can show that optical beamformer is a very nice technology to improve upon beamforming for millimeter wave antennas, to make the beamforming more versatile, to have multi-beam transmission, and to reduce the power consumption. So these are the main innovations of blueSPACE, where we have analog radio fiber transmission, we have optical beamforming, and we have the space division multiplexing in the fiber optical distribution network. Thank you.
My name is Christos Vagionas. I am part of the 5G-PHOS project, phase 2 project. We are here to demonstrate the fiber wireless 60 GHz link to demonstrate the front haul capabilities of analog radio over fiber optics. Within the 5G-PHOS project, we are deploying already existing technologies, optical technologies and integrated photonics to demonstrate analog radio over fiber solutions with ultra-high capacity and ultra-high density for 5G millimeter wave networks. Here we are demonstrating we are demonstrating an externally modulated laser developed by 3.5 Labs and a millimeter wave antenna by Ciclu. And the capabilities that we are demonstrating is 60G RF beamforming and optical beamforming fabricated by Lyonics. Within the project that we are developing, 5G-PHOS is targeting to bring solutions for 3 use case scenarios for rural areas that 5G traffic is going to be overlaid on PON networks, ultra-high capacity dense areas with multiple fibers and spatial division multiplexing, as well as WDM technologies for millimeter wave access and hotspot networks that are going to be installed in a football stadium.